Economic order quantity model for inventory control. This is a deterministic model as demand D is known for a specified period. In this case, we are taking the period as 1 year. Let D is equal to demand per year, which is known in units. C is equal to cost per unit of the material. CO ordering cost per order. CH is equal to carrying or holding cost per unit of time. And Q is equal to ordering quantity units. Total cost for the period, say year, is equal to material cost, ordering cost, carrying cost. That is DC is equal to DC d by QCO plus Q by 2 into CH. How this has come, I have already discussed in my previous video. The relevant cost is, that is TC dash is equal to ordering cost plus carrying cost. Why we are not taking this material cost? Because material cost is the deterministic cost. You cannot change it. It is not a decision cost. We have to take decision. That's why we are taking the relevant cost here. Ordering cost and carrying cost is the relevant, and we have to find out the formula for finding out the optimum ordering quantity for which the total relevant cost is different. The cost is minimum. Previously, we have found the economic ordering quantity with the application of calculus method. But those students who are not comfortable with the calculus method, for them I have done this approach. It is a graphical method. How the graphical method is applied to find out the optimum ordering quantity for inventory control, that I am going to discuss. See the graph. The x-axis is ordering quantity and the y-axis is cost. In this case, we are taking the relevant cost only. Now, see this graph. This graph represents the ordering cost, which is inversely related. Inversely means if the ordering quantity is increasing, then the ordering cost will be decreasing. Cost will be decreasing. That as Q is in the denominator, if Q increases, the total d by Q to C, the ordering cost will be decreased. That's why it is shown as inversely related. Now come to the holding cost or carrying cost. This is carrying cost. The cost is Q by 2 into CH. How this has come, that I have discussed in my previous video. Okay. We know the equation, the straight line is this. Y is equal to Ax plus C. If this is the equation, straight line, then C is cutting from the y-axis. We can write this carrying cost in this way. Carrying cost is equal to CH by 2 into Q into plus 0. That means this is representing the M, the gradient, and as C is equal to 0, that means it is passing through the origin. That's why the carrying cost line is passing through the origin. It is a straight line because it is in the form y is equal to x plus C, and C is equal to 0, and Q is the variable which represented as x. That's why carrying cost is represented by it. Now the total cost line you can see will be in this shape. Why? Because for each point this is the total cost. That's why you have to add the carrying cost and ordering cost. And definitely this is the ordering cost, and if you add the carrying cost, it will be slightly higher. If this is the ordering cost and this is the carrying cost, if you add, it will be higher. In this way, you draw the total cost card, and you can check the total cost will be minimum at the point where these two lines, at these two curves, that is ordering cost line and carrying cost line intersects, and that point is the point where the total cost will be minimum. We can use this concept for finding out the optimum ordering quantity. From graph, it is clear that the total relevant cost will be minimum when ordering cost is equal to carrying cost. This is ordering cost and this is carrying cost. If you simplify, then the optimum ordering quantity will come as this. The formula is same as we have calculated as per the calculus method for determining the optimum ordering quantity. And the rest portion is same, which I have discussed by previous video in the relevant video. that is number, how you will calculate the number of orders to be placed in a year and the time interval between two orders and the total cost for the period or year. Thank you.